The idea was that we really wanted to look at some local examples, no offense to the West Coast, at some of the things happening here, some of the partnerships between the utilities and some of the people in this room and colleagues of yours, and really show off some of the things that are happening here and some of the opportunities. So the first speaker is going to be Paul Lukitsch. Are you here? There he is. Okay. So Bill and I have the pleasure of working closely with Paul's brother, Mark, at Beth Israel Deaconess Medical Center. So I have lots of stories that I'm not going to tell, except to say that a couple of things that I think are relevant. One is that Paul is Regional Facilities Manager for Millipore, and is comparable to your situation, the New England Energy Engineers winner for the last year. And the campus as a whole, under his direction, was selected as the best corporate energy management program in the region, which is not inconsiderable, as you know, the competition, much of which is in the room. I will say that there was a 1967 Mustang as a young man that he restored from nothing to a showpiece that he still has. It almost bankrupted the family, supposedly. But the real story there from his brother is that he showed the attention to detail and to quality of service that you're about to hear about in the next presentation. Thank you.
I was told, 15 minutes, so I have about a dozen slides. So I'm going to go quickly on these. Just a little education on the clicker. Do we go? Okay. So Millipore, real quickly, Millipore makes all kinds of products. I can't even begin to tell you, 30 or 40,000 different products. But I'm going to focus in on this product in the right corner. It's called Mobius, and it's a very interesting product. And I have a little story to tell you. In 2006, Millipore bought a group of companies. One of the companies was in Anderson, California. It was a small mom and pop shop. And they made this product called Mobius. And in layman's terms, facilities terms, this is what Mobius is. If I'm a biopharma company, I make the soup, my drug. I make the soup in a stainless steel kettle that's insulated, has heating, cooling, mixing, injections, and all these odd things on it. That kettle cost me about $1 million. I can't use that kettle when I get it in that day because the kettle needs to be sanitized and it needs to be validated. That process is a minimum 3 to 6 months. So Mobius is a disposable solution. The biopharma company buys this, they take it out of the box, take it out of the bag, and they're making their soup on day one. It's a game changer. It truly is. Just to give you an example of how dramatic it is, typically the Anderson, California shop made about $1 million of product a year. And they were working hard, working 24/7. And Millipore bought them, and we just said, we're going to sell this nationally and internationally. And so last year, after moving this to Danvers, Massachusetts, they approached $50 million, and it's on a trajectory for $100 million in sales. And we can't make enough of this product. So redundancy, you're going to see in my talk, was absolutely critical in this project. We had to build that in, but very cost effectively. Because a moment of downtime means lots of lost revenue. So as a life science leader, we obviously want to build sustainable products. I could talk a long time about the product itself that I'm going to be speaking of, but that's not what my talk is today. Our operations, which is really what I'm going to address today, and obviously our people. We want to work in a sustainable fashion. But this is really about the Mobius Cleanroom project. And I made some notes earlier today. I think, Phil, you addressed labs, hospitals, and clean rooms. They use a lot of energy because they're moving air. And that air is not cheap. That air is usually heated or cooled, dehumidified. That's extremely expensive air. So using it carefully is very important. And then Matt also, he hit right on it. Variable air volume and the monitoring and the verification are key things you want to do. I just wanted to, echo those thoughts. So this clean room is a 10,000 square foot clean room. It's very large. We actually built 2 of them. They were LEED Golds and Gold projects, and that was very interesting because LEEDs is really geared around office or labs where you can put windows in. You can have individual controls for people. You can't do that in a clean room. We put a window in a clean room would not work well. Giving people individual temperature controls in a clean room wouldn't work too well. So we had to be really innovative on how we gained those points to go to gold. And I'll explain one of the processes we used. So it's an ISO Class 7 clean room, obviously validated facility, and we were expanding this product line extremely fast, exponentially, and we still are. It's a 24/7 operation. Redundancy was absolutely key. We had a hard budget to build this project, and redundancy was the key thing here. So I kind of joke around a little bit, and I said clean rooms are typically set it and forget it. You build it, you commission it, and you walk away. It's kind of like the Ronco cooker, right? You set it and you forget it. Well, it's a big mistake. It's a huge waste of energy. The filtration and the airflow systems are often designed, if they're designed correctly, the clean room is cleaner than it needs to be. For instance, if we're not making the Mobius bags on the weekend, why do you need to run all that air? Slow it down. Clean room simply is a box within a box. So we have an outer box and an inner box. We have our air handler on the roof. We're supplying our HEPA filters, high efficiency particle air filters. We're supplying those with the air from the air handler, and we're returning them through a return air wall. That's basically acting like a piece of ductwork. So we reduce cost by eliminating half of the ductwork. We use the wall as a duct. We don't build in all that extra ductwork to return the air. We eliminate that. By doing that, you eliminate the need for duct insulation, because that space above the, that space above the ceiling is all conditioned air. So you don't need to insulate that ductwork. And that also really works in your favor because it reduces the pressure drop from putting it through a small ductwork versus that plenum. This is the key slide here, and I don't really want to make a science project out of it, but the room we're sitting in right now is probably about 6 to 25 air changes an hour. Clean rooms, anywhere from 500 to 600 air changes an hour. Okay, so if you can run that clean room close to what we're in right now, you're going to save a tremendous amount of energy, and I'll show you what we did. These are some charts I stole off the internet, but that's a Class 7 clean room. It's actually ISO 7, Class 10,000, and they recommend 60 to 90. So if I'm the engineer, I'm going to sit down and I'm going to draw everything, design all my fans, my ductwork, et cetera, to give you 90 or maybe more air changes per hour. So it's really based on old practices, and really, it's not based on any fact. We didn't really want to settle for that. We wanted to challenge ourselves. We felt we could get innovation points for LEEDs. So we started to look at what we could do. And one of our smart folks on the team said, why don't we really measure air changes and particulates and adjust those air changes accordingly? If the room and the product we're making is clean enough, slow it down, slow it way down. Still get good mixing and good stratification of that air, but slow it down to a safe minimum. And that's really what we ended up doing. I'm not going to read all the bullets for you folks. Here's actually the picture. We installed 2 particle counters. I think the particle counters cost about $6,000 each. The programming, probably about another $10,000. So for $16,000, we had our particle counter system installed in our clean room. We were able to reduce our air change rates by more than 50%. We also did some other things. We installed direct drive fans. So clean rooms are very, very touchy about dust, obviously. Belts spinning for days and years on end are going to produce a lot of belt dust. So direct drive fans, and also the bearings are very long life bearings. That's a robustness measure we put into it. And then obviously having 2 air handlers. One is a backup of the other. We run them only at 50%. One fails or we have to maintain it. You do have to maintain things once in a while. You shut one off, we automatically open up the air to the other side of the room. Works quite well, actually. Our maintenance guys love that. These are just some pictures of direct drive fans. You can do this method in various ways. You can use, obviously, single fans, 2 speeds, 3 speeds, variable frequency drives. You can use fan walls. I saw David Bellevue here. He's talking to me about some fan wall units. And you can use some fan filter units. But one interesting part of this project was this is in a 1960s building. And it was built like the parking garage across the street. It has a cement T roof. Very unusual construction. And so we're into the LEEDs process. And one of the things about LEEDs was, let's do some commissioning on this. But we hired the enhanced commissioning portion of this to get extra points. So our commissioning agent's walking around with a thermal camera. He says, hey, Paul, look at that cement T roof. Look at how much air leakage you're getting around that and how much conductivity of the cold from the outside you're bringing in through that cement. Right away, we said this is going to be a huge problem because we're going to have probably a moisture issue above our clean room. Moistures in clean rooms leads to mold. It's not a good thing. So right away, this keyed us in, and we said, we really need to address the insulation on the building. It was an old building. It used to build stoplights years ago. And it had an R factor of 1. I remember standing. It was actually snowing in the building at one time. And I said, that's not good. We're going to build a clean room here. So I was easily able to justify a project, and we insulated the side of the building up to R22 and solved that issue right away. I'm not a LEEDs fanatic, and I hope nobody from here is from the USGBC, but ironically, once we installed this system and we put in for the innovation points, they scratched their heads and they said, we have no idea what you're talking about. We said, well, let's explain it. We went through it with them. We gave them all the data, and they said, still don't get it. No points for you guys. So after we did all this, we didn't receive any additional points, which was very unfortunate, but we know we did the right thing. Because here's the money slide. I say this is our set it and forget it line. That's a typical clean room. That's the way it would run if we didn't do this process. That's the way most clean rooms around the country are built. And our green line indicates how it actually runs. It's 71% savings from those two fans. That equated over those two clean rooms about $51,000 a year. So I said we spent roughly $16,000 each unit. So nice payback on that. And here's the other money slide, the results. The clean room runs, it's a class 10,000 clean room, and it runs usually about class 1,000 consistently over time. So the clean room, even with that variable frequency drive on the unit, still runs is much cleaner than it needs to be. And actually, there's my question slide, but that is a picture of a conference room that we purposely built with a glass wall in it. The reason why we did that is typically customers want to go into your clean room. And we said, that's not good. We don't want them in our clean room. But they want to see our process. So we said, well, why don't we build a conference room with a glass wall and a set of automatic blinds? So we give them our presentation, and we said, you want to see our clean room? We hit the button, it opens up, and said, there it is. And they, do you want to go in? Nah, we're all set. We see everything. So it's quite effective, actually. It's an impressive facility. We're very proud of it. We've built another clean room just like this, and this product line has taken off extremely well, so we're probably going to build more in the near future. That's it, folks. Thank you.